Copper proteins are proteins that contain one or more copper ions as prosthetic groups. The metal centers in the copper proteins can be classified into several types. Type I copper centers, T1Cu, are characterized by a single copper atom coordinated by two histidine residues and a cysteine residue in a trigonal planar structure, and a variable axial ligand. Amocyanin, plastocyanin, and pseudoazurin, the axial ligand is the sulfur of methionine, whereas amino acids other than methionine, E.G. Azurines contain the third type of T1Cu centers. Besides a methionine in one axial position, they contain a second axial ligand, a carbonyl group of a glycine residue. This may be misleading, since some T1Cu centers also absorb around 460 nm and are therefore green. When studied by EPR spectroscopy, T1Cu centers show small hyperfine splittings in the parallel region of the spectrum, compared to common copper coordination compounds. Type II copper centers, T2Cu, exhibit a square planar coordination by N or N/O ligands. They exhibit an axial EPR spectrum with copper hyperfine splitting in the parallel region similar to that observed in regular copper coordination compounds. Since no sulfur ligation is present, the optical spectra of these centers lack distinctive features. T2Cu centers occur in enzymes, where they assist in oxidations or oxygenations. Type III copper centers, T3Cu, consist of a pair of copper centers, each coordinated by three histidine residues. These proteins exhibit no EPR signal due to strong antiferromagnetic coupling, I.E. Spin pairing, between the two s equals 1/2 metal ions due to their covalent overlap with a bridging ligand. These centers are present in some oxidases and oxygen-transporting proteins, E.G. Binuclear copper A centers, Qua, are found in cytochrome C oxidase and nitrous oxide reductase, EC 1.7.99.6. The two copper atoms are coordinated by two histidines, one methionine, a protein backbone carbonyl oxygen, and two bridging cysteine residues. The copper atom is coordinated by three histidines in trigonal pyramidal geometry. The four copper atoms are coordinated by 7 histidine residues and bridged by a sulfur atom. B. Reactivity of dioxygen copper systems, Chemical Reviews 2004, 104, 1047-1076.